This tutorial will show you how to conduct a two-sample chi-square test of independence in SAS. We will be using the weights dataset for this tutorial. In SAS, you can find the programming code in the SAS tutorials folder. It's called chi-square tutorial. You can copy it to your class stat folder and double-click to open. Our research question is, was there a significantly higher proportion of low birth weight babies born to mothers with a history of hypertension compared to those without a history of hypertension? For this question, the outcome is having a low birth weight baby, and the exposure is a mother having a history of hypertension. We can check the weights codebook to make sure both variables are categorical, and we can see how they're coded. 0 for no and 1 for yes. The research question is asking about a significant difference between two groups. We know that our outcome variable is categorical, low birth weight or not. Next, we know that we want to compare proportions of that outcome variable in two separate groups, mothers with and without a history of hypertension. So we can conclude that a two-sample chi-square test of independence is the correct test to answer the research question. For a chi-squared test, the null hypothesis is that there's no association between the two variables. That is to say that the proportion of the outcome is not significantly different in the exposed and unexposed groups. The alternative hypothesis is that there is a significant association between the variables, meaning that the proportion of the outcome is significantly different in the exposed and unexposed groups. Here you can see what the null and alternative hypotheses would be specifically for our research question. And now on to checking assumptions. We know the first is met because there are two variables and they're both categorical. We'll have to generate a bivariate frequency table to check there are at least 5 observations per cell. And we know the third assumption is met just by the nature of the data. We don't have data that contains people at 2 different times. Now you can run your libname statement, and then you can run the code for the chi-square test. Chi-squared requests the chi-squared statistic and corresponding p-value, and relative risk requests the relative risk, which, remember, can be relative prevalence if the study is a cross-sectional design. The first table in the output is a bivariate frequency table with the extra percentages here. If you didn't want these percentages, you could say no row, no col, no percent, and then you would get a table with only the raw numbers. The next table shows the chi-squared statistic here and the corresponding p-value here. We can see that if our alpha is 0.05, this p-value is significant. For that reason, we can reject the null hypothesis. We can conclude that there is an association between the two variables, low birth weight and history of hypertension. That is to say, the proportion of babies who are low birth weight are significantly different for those born to mothers with or without a history of hypertension. And we can actually see in the table that the percentage of babies born low birth weight to mothers without hypertension was 29.38%, while the percentage of babies born low birth weight to mothers with hypertension was 58.33%. And we can conclude, based on our p-value, that these are significantly different, and so these two variables, history of hypertension and low birth weight, are associated with each other. And finally, we can interpret the relative risk. Since this study is cross-sectional, relative risk is actually relative prevalence, also called prevalence ratio. And that's because it is the ratio of the prevalence of the outcome in the exposed group compared to the prevalence of the outcome in the unexposed group. So that means the relative prevalence here, or prevalence ratio, is the prevalence of low birth weight babies among moms with the history of hypertension divided by the prevalence of low birth weight babies among moms without a history of hypertension. And I should note here, before I provide a final interpretation, that I did get this warning: 25% of the cells have expected counts less than 5. And so these are the 4 cells that it's talking about, and the one in question is this one with 5 observations. And actually that's the minimum value you can have for the chi-squared test. So I'm going to say that the assumptions of the chi-squared test are actually met and conclude that it's a valid test. So my final interpretation of the chi-squared statistic is that a history of hypertension is associated with having a low birth weight baby, and I add my chi-squared statistic and the corresponding p-value. My final interpretation of relative risk, which remember is actually relative prevalence or prevalence ratio, is the prevalence of low birth weight babies was significantly higher among mothers with hypertension, 58.33%, compared to those without hypertension, 29.38%. And I would add my prevalence ratio, or relative prevalence, statistic of 1.69, as well as my 95% confidence interval.